So let's look at the following example. Let's find the maximum value of your function f of xy equals 4xy, where x is greater than 0 and y is greater than 0, subject to the constraint that x squared over 3 squared plus y squared over 4 squared equals 1. So the first thing we're going to notice is that this is our constraint equation. It's equal to a constant, so we can identify that as our g function. And now I can take my function f, and I need the gradient of f. So what's the gradient of f going to be? Take the derivative with respect to x, you'll get 4y, and the derivative with respect to y, which will be 4xj. Now look at your g function here and take lambda times the gradient of g. So you're going to get 2 lambda x over 9I. That's the partial derivative with respect to x times lambda. And then the partial derivative with respect to y. You bring 2, so it'll be lambda y over 8j. So now let's write out our system of equations here that we need to solve. So you're going to set the I components equal. So those right there. So your first equation will be 4y equals 2 lambda x over 9. Set your j components equal. You'll get 4x equals lambda y over 8. And then your third equation in your system of equations is your constraint equation, x squared over 3 squared plus y squared over 4 squared equals 1. So here's our system of equations that we need to solve. So what we're going to do is we're going to take this first equation and we're going to solve for lambda. So lambda will be, if you solve for lambda, you'll get 18y over x. And you're going to take this and you're going to plug it into your second equation there. So plug into second equation. So I'm going to have 4x equals, now in place of lambda, you're going to put 18y over x times y over 8. And so if you multiply here, we're going to get, multiply by x, you'll get 4x squared equals 9y squared over 4. So if I solve for x squared, you're going to get x squared equals 9 over 16y squared. And now you're going to take this and plug it into your third equation. So here you had 1/9 x squared plus y squared over 16 was 1, and you're going to replace x squared by 9 over 16y squared. So the 9's cancel, and you're going to get 2 y squared over 16 equals 1. So this means y squared over 8 equals 1. Y squared equals 8. Y equals plus or minus 2 square roots of 2. But remember that we were told y had to be greater than 0. So because of that, we're going to get rid of the negative. And once we know y, we can figure out x. So I go back to our equation where we had x squared was 9 over 16y squared. X squared equals 9 over 16. Y squared is 8. So x squared equals 9 over 2. X equals, so I'll just go over here, x equals plus or minus 3 over the square root of 2. But again, we were told x is bigger than 0. So we toss out the negative. So we get that the maximum value of f is f of x was 3 over the square root of 2. Y is 2 square roots of 2. So it's 4 times 3 over the square root of 2, 2 times the square root of 2, and you can cancel these square roots of 2. And so your final answer is 24. And that is the maximum value of our function, subject to our constraint.